Well, welcome to lecture number 55, studying circuit analysis. And in this lecture, we'll start studying three-phase systems. Three-phase systems are studied due to many advantages over single-phase systems. For example, they are cheaper to generate electricity and transmit and distribute. Economically, three-phase systems are the most viable systems to produce and distribute, transmit and distribute electricity. Right. A three-phase system is composed of wires, three wires, namely A, B, and C, corresponding to three different voltage sources. Each one of them is, for example, is 120. This is the peak voltage. It can be any voltage. It is, for example, this is only, for example, 120, an angle of 0. This peak voltage having the same magnitude. This is only for example. It is generally VP. This is also VP, but at an angle of minus 120. And this is also the same peak voltage at an angle of minus 240 degrees. And all these three voltages are measured with respect to a common terminal. We call it the neutral terminal, this one. So this VAN is measured by putting a voltage measuring device between terminal A and neutral. Similarly, VBN is measured between B and N, and VCN is between C and N. So all these three voltages are same in magnitude, not necessarily 120. They can be 240 or can be any number, but the magnitude is the same for all three voltages. However, the angles are different. 0 degrees is minus 120. This is minus 240 degrees. Right, graphically, they can be represented as VAN. They reach to a maximum voltage, the same max voltage, VB, VAN. If VAN is drawn with this blue color, with this dark blue or purple color, we have this VBN drawn. It starts after 120 degrees. VAN was started. VAN was started from 0 degrees. So VBN starts after 120 degrees. Similarly, VCN starts 120 degrees after VBN, or 240 degrees after VAN. So this VBN is delayed by 120 degrees and VCN by 240 degrees. Right, so we have these three voltages, exactly same in magnitude, but they differ in phase. So three-phase is more economical to generate than single phase. Three-phase transmission and distribution is also cost effective compared to single phase. These are few advantages of using three-phase over single phase. A balanced three-phase circuit is the one which satisfied this condition: VAN plus VBN plus VCN is 0. Since all these three terms are complex terms, right? They are complex. Why complex? Because we have a magnitude and a phase term. So therefore it's a complex number. So all these three numbers corresponding to VAN, VPN, and VCN, they are complex numbers. Right. So a balanced three-phase circuit satisfies this property, that vector sum or the sum of these three complex numbers is 0. So we can straight away prove that using using the knowledge of complex numbers that we already have. VP at an angle of 0, this means this is VP at an angle of minus 120. This is the same as R at an angle of theta, and we know that we can convert this polar number into rectangular number, like x is equal to R times cosecant of theta and y equals R times sine of theta. So we'll replace this number VP at an angle of minus 120 with VP cosecant of minus 120 plus J VP sine of minus 120. Similarly, this complex number is also written in its rectangular form. Once we have done that, we know that cosecant of minus 120 is minus 1 by 2, sine of minus 120 is minus under root 3 by 2, minus 1 by 2, and this is cosecant of minus 240 is minus 1 by 2, and sine of minus 240 is minus under root 3 by 2. Right. So if we add them together, we get 0, because this minus 1 by 2 and this minus 1 by 2, they become VP. So they cancel and these two cancel. So the answer is a 0. So we can straight away verify that for any value, any given value of VP 120 or 240 or for any other value, the answer is a 0. Right. Then they can represent the same as a phasor diagram. If we have VAN at an angle of 0, VBN is plotted at an angle of minus 120, and this is VCN. I missed it. This is VCN. It is at an angle of minus 240, going clockwise. But we can also represent this minus 240 as plus 120 if we go counterclockwise. So minus 240 angle minus 240 degrees is the same as plus 120. So if you move counterclockwise by 120 degrees counterclockwise, we reach to 120. It's the same point as we reach by covering minus 240 degrees by moving clockwise in clockwise direction. Right. This is all for today's lecture. In our next lecture, we'll study two types of three-phase systems most commonly used in the real world systems. They are star connected and delta connected systems, and we will also study their properties. Thank you.